Heart anomaly detection using deep learning approach-supported signal analysis. Phonocardiography is an effective technique which helps for the recording of heart sounds during the heart cycle identification and further diagnosis of human-related diseases. Heart contraction of the heart muscles and closure of the heart valve. The heart produces sound, which can be analyzed by the experienced cardiologist. The aim of this study is to create an automated classification method using a one-dimensional solution neural network based on phonocardiogram data for discrepancies in the heart sound. The proposed system consists of 3 phases. 1. Data acquisition. 2. Pre-process. 2. 3. Feature extraction and classification. We have proposed an intelligent neural network approach for the classification of PCG data. Heart sound recording, PCG data, which is nothing but an audio file converted in its time domain representation. This is provided as converted PCG data input for the neural network. Was also emphasized on noisy heart sound recording. It can reduce noise efficiency classification because it disrupts the values of the neural network. The accuracy of the proposed system is 91.5% with sensitivity of 0.92 and specificity 0.91. Keywords: convolution neural network, PCG data, phonocardiogram, heart sound. 1. Introduction. According to the World Health Organization, WHO, cardiovascular disease, CVD, is the most common cause death globally. CVD kills more people than any other disease in the world. More than 17.5 million people worldwide have died as due to cardiovascular diseases. About 610,000 people every year in the United States die of heart disease, is the same. More than 29% of total deaths and 1 in 4 deaths 2004 is due to cardiovascular diseases and is number 1 is increasing every day. Coronary heart disease, CHD, is the most common type of heart disease. 37 kills more than 370,000 people annually. Existing methods of finding the primary signs of abnormalities in the heart are very expensive. They may not be where it is cheaper in underdeveloped and developing countries. The economic condition of the country is not so good. So, there a possible and reliable system is needed for early detection heart disorders. Any method that can help you find its signs of heart disease can therefore have a significant effect on world health. A stethoscope is an acoustic medical device for isolation or for listening to the internal sounds of the human body. That is a primary device for hearing the heart sound. The advantage of this is to use an electronic stethoscope over an acoustic stethoscope. Its properties like amplified sound output, enhanced frequency, range, ambient noise reduction, etc. It includes an amplifier to amplify low-intensity heart sound. Electronic stethoscopes transmit sound electronically, therefore, it can be wireless. Can be a device or a recording device. It can also provide a scene performance of recorded heart sound. PCG recordings have 4 heart sound signals, i.e. S1, S2, S3, S4. The first 2 are normal heart sounds. Normal heart valves are produced by opening. S3 and S3 have unusual heart sounds like S1, S2 and S4. These unusual sounds are called rumblings. Current medical testing techniques that can detect the deformity. Heart sounds are very expensive. It is not affordable for the average human being. So, the main challenge is to develop such accurate, reliable, and affordable technology. Heart sound is still the primary tool for detection and analysis of the condition of the human heart. Proper interpretation of the state of the heart is largely based on experienced cardiologists. It can be fraught with error. More reliable computer-based technology needs to be developed. Several methods are being suggested for the medical system development for the diagnosis of heart disease. The purpose is ours. The study aims to propose an intelligent algorithm to determine the presence of abnormalities in the sound of patient data. Also, with this we wanted to make it possible and affordable solution. 2. Methodology. The proposed method 1 in this study is the basic 3-step architecture. 1. Data acquisition. 2. Pre-processing. 3. Classification. 2.1 Data acquisition and data preparation. Use of datasets for supervised machine learning purposes. Pascal is a dataset that includes the sound of the heart artifact, recordings labeled by 3 categories of common name heart sounds and abnormal heart sounds. About 400 HS files there is in the Pascal dataset. In the processing step, we made 2 identical copies of dataset. In the first copy of a dataset, labels are common and the unusual is replaced by a non-artifact label. This is done for signal quality assessment. Analogs are converted after HS in the domain introduction of his time 2. The advantage of converting analog data to a time domain is analogs. The data is converted into a statistical equivalent representation which a machine is an understandable structure and it is also easy for the purpose of analysis. There can be various mathematical functions analysis which applies to statistics and can be used for so time domain introduction is very important. The input size of CNN is already fixed. So, the recordings some have to be converted to a certain length before training. 3. We converted the signal into fixed size data of 8 to 11 seconds. If it is longer than the specified time, we cut the data in fixed size. If it is short, we extend it by repeating the original signal to make it to the original length. Downsampling is applied to omit ineffective data. Downsampling improves normalization on datasets. Is there some really low-frequency noise recorded electronically? Stethoscope, especially the rumble that passes through one low-pass filter that allows low-frequency sound to pass through and finally reject the sound from the data. So, this is the first step towards filtering out noisy data. 2.2 Signal Pre-processing. The signal is pre-processed for quality assessment heart sound files. The artwork contains sound files sound with data that is weak with quality. The HS. The signs are not suitable for classification. 2.3 Feature extraction and classification. The signal quality assessment block 4 ensures that these files should be deleted. Now the dataset is only with good quality audio duo files which is potentially fit for classification. Fig-1. Proposed block diagram. CNN can be useful for classification and can be used classified as good or bad quality 5. So, here are the advantages. Neural networks are exploited for signal quality assessment. Classify heart sound files into good quality files free from noise and poor quality files that contain artifacts. The heart sound dataset is given to the convolution neural network which classifies data into two categories called artifacts and non-artifact. The main reason for doing this is to prevent values of neurons due to distortion. While training neural network, values of neurons in each CNN comes closer and closer to the real value and therefore functionality of the features presented on the neural network grows slowly. So, if we delete the recordings in them artifacts, we can increase the efficiency of classification. Neural networks are therefore also known as CNN1. Good or bad classifying a quality signal can also be seen as a first step towards increasing the accuracy of the system. Greater accuracy of CNN1 to better filter poor quality signal. There will be a demonstration of CNN2 for general and classification. There will be an unusual heart sound and therefore better performance of the system. The convolution neural network is mainly composed of two parts, feature extraction and classification. Section of feature extraction is responsible for automating effective features from PCG signals. Classification part of it uses the feature of reacted. In short, these two the departments carry out the main work of this paper in a cooperative manner. For binary classification, the last layer has two neurons shown. It can also be done using one neuron, but only for the better presentation and understanding we have selected for two neurons one instead. Fig-2. Proposed processing methodology. The following purpose in the implementation of the neural network. Left, PCG data, .wav file, is converted to binary data fixed length using time domain representation which is next board of the CNN model. Right, CNN architecture includes a lot convolution and maximum pooling levels, batch normalization levels fully connected or followed by dense layers. 2.4 Dropout Layer 6. The term dropout means leaving units, both hidden and visible, in the neural network. That's the decent thing to do, and it should end their performance of the average model with a neural network. Model the average is a natural response to the uncertainty of the model. The dropout level allows regularization by random setting 0 some neurons in the previous layers during training. 1. Max pooling 6. Max pooling is intended input presentation for downsample. It helps eliminates dimensionality and convenience extraction. It reduces computing cost by reducing the number of parameters to learn. Batch normalization allows each level of the nerve A network for learning a little more independently another level. It reduces overfitting and increases stability neural network. 2. Batch normalization. Batch normalization allows everyone the level of the neural network for learning a little more independently than the second level. It reduces and increases overfitting stability of the nerve network. 3 Results. General and absolute accuracy of the classification system. Abnormal heart sound is 91.5%. The accuracy of a good or bad quality classifier or CNN1 that is responsible for the signal. The quality assessment is 86.7%. For conclusion. This study is very complex and attempts to solve the complex problems in the medical field. It tries to classify the heart sound is obtained by PCG in normal and abnormal heart sound. This will significantly help the healthcare industry. The highest number of deaths worldwide is due to the heart-related problems. The method adopted for classification. There is a technology in computer science known as neural network. The use of a one-dimensional neural network is demonstrated. The model proposed in this study demonstrates a novelty approach to classification of noisy data containing artifacts. The first step is quality assessment. The advantage of this step: voiced data does not disturb the original neural A network that is used for the classification of good quality heart sound file in normal and abnormal heart sound. Instead, a separate neural network is used for the same purpose, i.e. classification of noisy heart sound data from good quality heart sound data. The limitation is that the system will not produce significant satisfactory results if the data set contains more files noisy data.